I would like you to search hands-on gradient boosting with XGBoost and scikit-learn GitHub. It's a bit of a mouthful. I go here to use data sets. This is a book that I wrote, and so I know what the data sets are that are in it, and I'm going to show you one of the reasons why. Okay, this is a machine learning book. You'll learn in this class like what XGBoost is later. We've already started with scikit-learn. So when you search that, go ahead and pull up the link that you get, and I want you to go to chapter 3. Okay, so inside of chapter 3 here, what you'll see is this census cleaned CSV file. So basically these data sets are cleaned and ready for machine learning. And so when you see that, go ahead and click on it. And then you want to click View Raw. After you click View Raw, copy in that URL, highlight it, Command-C or Control-C on a PC, open up a new Colab window, go to a new notebook, and what we're going to do now is pull this data set up. So put in the URL as such in quotes, and then the usual import pandas as PD, followed by df equals pd.read underscore CSV, the URL, and then let's take a look at this data set with df.head, and we'll start by naming this perhaps census data set, but we're also going to use what's called logistic regression after we motivate y. So this is our data set. It has these columns here, and this is a census data set, and you can see at the very far right, this is generally what you're trying to predict, which is whether somebody makes more than 50K or less based on all this other information. So what we are going to do now is, this has been cleaned, so we're going to use basically our Y value, and I'm going to put it in the top here. So this can be a machine learning kind of data set. And basically, like when you're working on your projects, you want to put all sort of your machine learning prep in one code at the top. And then it just becomes a machine learning notebook. You don't need to run a bunch of coding cells to establish X and Y. So Y is the last column, that's index location, all rows, just the last column, and capital X is the index location, all rows, all columns, all the way up to and excluding the last. Okay, that is the inputs that we're going to use to the machine learning model. Now, before we do this, okay, I want to look at a regression plot of this. And I just want to compare, let's pick, something that could influence, whether somebody makes more or less than 50K, like their education number. Okay. And so what we're going to do, we're just going to quickly import matplotlib.pyplot as PLT, and then we're going to import Seaborn as SNS. We get a nice little background, and we're going to do an sns.regplot. We've seen this before. This is going to give us a linear regression line. Our data is going to be df, and X is going to be, we've already, I think they want it as, this is a single column. So we want education num here. And then what is our Y? Well, if we go to the far right, sometimes this can be weird to type in. So just you can actually get in there and copy it with your mouse, that way you make sure that you have it correct. And then let's go ahead and show this, okay? So just doing traditional regression, and there's a reason why I want to show this to you. Okay, so I got it wrong. Education num, this is why I can get to copy it too. It looks right. Oh, see, there's an extra space there, which is unexpected. Okay, so we use copying and pasting. Well, maybe the hyphen's different. Okay, and you have it. Now, okay, this is interesting, right? And the reason why I'm showing you this example is because if you are trying to capture the relationship between this data, even if you imagine, so here we have like a bunch of different educational numbers, you can see that there's not really much of a relationship, but imagine even if there was. Imagine that you had more dots here to the right. Well, and you might, we could check to see, can we just use the regular alpha in the sns.reg plot? I'm not sure. No, it doesn't work. I could look up that later, how to set up the alpha, but that's not really the point. So what's the point? You can do it, by the way, but it's just done slightly differently at Seaborn. So what's the point here? The point is that linear regression is the wrong model. Okay, like I don't care where, like the reason why is because no matter how, like how the x's influence it, all the dots are zeros and ones. Okay, so like it doesn't matter which column you pick. We could pick another one, like age. I mean, age could definitely have something to do with it, right? If you're too young, you're probably less likely to make so much money. And yeah, I get, well, you can see it's similar. This is not the right model. Okay, that's what I'm trying to express. If you had a project to start with linear and we did linear regression, you may have gotten these weird kind of plots and bad results just because you're using the wrong model. And imagine this when we're using all of this data. Okay, you're not going to get good results because what does linear regression do? Okay, what it does, like let's just say someone's got an age of, I don't know, 45. Okay. Is their income greater than 50K? Well, the linear regression model gives like 0.3, which is meaningless. Now, you could choose to round it down, okay? That's sensible. It's just simply, I keep saying this because I want it to come across, it is the wrong model. And the reason why is because this data set, because it's split into two, requires classification, okay? So that's what we're going to learn how to do. We're going to learn how to classify data into two groups. And the classifier that we are going to start with is called logistic regression.